Hi, this is Tim. Today we're going to take a deep dive into the features of the PLC Tools SIM-ALP2 analog simulator. This device is very popular with technicians that need to simulate 4 to 20 milliamp current signals and 0 to 10 volt signals in fields such as industrial automation, HVAC, and the oil and gas industry. We're going to simulate signals to both a basic multimeter and to a PLC, since those are the two most popular connections. The first time you power up your SIM-ALP2 is going to come up with this quick start guide. And using the SIM-ALP2 is really as easy as 1, 2, 3. First, we're going to select our mode. And it can simulate a 4 to 20 milliamp 2-wire device, a 4 to 20 milliamp current sourcing device, or a voltage source. Once you select that, then at the bottom, it is going to tell you what you need to connect to which post to simulate your circuit. Then you're going to use your up and down arrows to adjust the output signal. If you need to get to the quick start guide at a later date, just go to settings and then you'll see the quick start guide. The current 2-wire loop and the current source are both 4 to 20 milliamp signals. So let's start by distinguishing when you need which one. Let's say you want to simulate something such as a pressure sensor that only has 2 wires coming out of it. Well, in that case, it will be a 2-wire current loop. On the other hand, if you have a pH transmitter that is externally powered, maybe by 120 volt, and then it has a plus milliamp and a minus milliamp terminal completely separate from that, then it is probably going to be a 4-wire device, which we would use the current source mode to simulate. It can be confusing to try to figure out how to wire a current 2-wire device compared to a current 4-wire device. The key is to understand the current 2-wire device is passively powered, whereas a 4-wire device is actively powered. Basically, that means that the 2-wire device will consume a little bit of power from the current loop to power its electronics. A 4-wire sensor isn't powered by the 4 to 20 milliamp circuit, so it only has to worry about regulating the current signal. Here is an example of a circuit for a current 2-wire device. We have a 20 volt DC power supply, and the plus of it will connect to the plus of the 2-wire device. Then the minus of it will connect to our PLC input, or the plus of our meter. And then our common of our PLC, or the black lead of our meter, will go back to the minus of the power supply. In the case of a 4-wire device, the 24 volt DC power supply doesn't even need to be there. It's going to generate its current loop internally. Now, it'll be powered by something else, but our plus milliamp signal of the 4-wire device will go to our PLC input, or the red lead of our meter, and then the common of the PLC, or the black lead, will go back to the minus of our 4-wire device. Let's start by simulating a current source, or a 4-wire device, to a basic multimeter. If we look down here, our middle post says MA for milliamp. So that is where our red post needs to be. And then our black post will be on the common. And we want to go over here to the amps DC area, but we want to make sure we're on these milliamps. And I'm going to select 20 milliamp. And then on the ALP2, I'm going to select current source mode. And then at the bottom of it, it says PLC input should be the red post and our common should be the black post. In this case, our PLC input will be our voltage input from our multimeter. So the red lead will go to the red post. Also, you can simply stick them in the top, or if you unscrew these posts, then you'll find that you can slide a wire through it and you can tighten it down. That way it'll stay in place. Now we can use the up arrow and drive our milliamp signal up, and we'll see the same signal on our meter. And we can bring it all the way up to 20 milliamp. And we'll see 20 milliamp in our meter. Actually, by default, the full range is 0 to 22 milliamp. So we can also simulate broken wires and faulted sensors, since many transmitters will put out 21 milliamps when something is wrong with the device connected to them. If you get to this point and your meter is not showing what the ALP2 says, then double check the connections down here on your post, because every meter is going to be different. So make sure that it is milliamps. Like in this case, we could be over here on this 10 amp one, but that's not going to read milliamps. So verify that and verify your position. And if you still can't read the signal coming out of the SIM-ALP2, then check the fuse in your meter. And I'll put a link to a video down in the description where I go into detail about how you can blow the fuse on your milliamp circuit and your meter still appear to work just fine. Now let's simulate that same signal to an Allen Bradley Micro 800 PLC. And I've also made it where we can see the value really clearly over here on the panel view. To simulate a current source, we're going to need to connect a wire to the current input, and we're going to use input 0 for this, so CI-0. And then we're going to need a connection to the COM terminals. We're going to use these two wires. And since CI is a current input, our terminal assignment says the PLC input is the red post. I'm going to connect that there. And then we're going to connect the common to the black terminal. Now you notice we didn't actually have to connect the common of the SIM-ALP2 to the common of our PLC power supply. And that's because in current source mode, the entire milliamp circuit is generated by the two AA batteries inside the SIM-ALP2. Now we're showing 20 milliamp on the SIM-ALP2, and we're also showing 20 milliamp on our display. And we can use our down arrow and run this on down. To 4 milliamp. Now let's say that we needed to run this up and down and up and down, and we could do that with the arrows, but after a while that would get a little tiring. If we press the OK button while we're in one of the simulation modes, then we're going to come up with 3 different output cycles. We have the sweep cycle, the step cycle, and the custom profile. If we click the sweep cycle, then we have 3 parameters that we need to set in order to use it. So we have the full sweep time, and this is how long from the starting value to the final value. And then we have our start value. And I'm just going to make our start value 4. And we have our final value, and I'm going to leave that at 20. And let's just go back to the sweep time, and let's make our sweep time 10. And now we'll go to run cycle, and we see our milliamps going up, and now they're going to go back down, and it's going to repeat, and we can also see it doing it on the graph. And another useful feature while you're in the sweep mode, the step mode, or the custom cycle is you can press the up arrow, and it's going to bring up a graph showing exactly what it is outputting. If we put these side by side, then we can see that the graph on the SIM-ALP2 is matching what we're seeing on the panel view. To get out of the graphing function, just press the down arrow, and that'll take you back to where you were. Also, at any moment during this, if you want to pause it, just press the OK button. That's going to pause it, so I've just paused at 13.5 milliamps. And we see that our signal is paused right at 13.5. We can press the OK button again, and it will resume the sweep cycle. Next, we have the step cycle. And in it, we have a step time, which I'm going to set at 3 seconds. We have a step size, which I'm going to set at 4 milliamp. We have a start value, which I'm going to set at 4 milliamp. And we have a final value, which I'm going to set at 20. Now we go back up to run cycle. And now it's going to jump from 4 milliamp to 8 milliamp. Next it's going to go to 12, 16, 20, and then it's going to start going down. 16, 12, 8, 4. And again, if we press the up arrow during this, we're going to see that same stair-step pattern that we're seeing on the panel view on the screen of the SIM-ALP2. Same as with the sweep cycle, I can press the OK button at any time and it's going to pause it. So now we're paused at 8 milliamps and we can see that our signal is paused. And I can press OK. It's going to go back to simulating our steps. I can use the down arrow and I can see the actual value here. And finally, we have the custom profile. And in this cycle, we can program specific values we want it to cycle through, where the sweep and the step go from a start value to a final value and back down. In this case, we can program it to go up, down, any particular cycle that you want, up to 10 steps. So our step time, I have set to 2 seconds. Our number of steps I have at 4. Step 1 is going to be 4 milliamp. Step 2 is going to be 12 milliamp. Step 3 is going to be 8 milliamp. So notice I didn't incrementally go up. I'm going from 4 to 12, back down to 8. And finally, step 4 is going to be 20 milliamp. I'm going to press the run cycle button. And we're at 4 milliamp. Now we're at 12 milliamp. Now we're down to 8. Now we're back up to 20. And it's going to repeat. And same as with the sweep and step mode, I can press the up arrow and bring up a graph showing exactly what it is doing. And if we put it side by side with our screen, then we can see that our custom profile trend on our SIM-ALP2 is following the values on our panel view. And I can use the down arrow and go back to where I see our current scaling. And I can go cancel and go back out and change values. Now let's talk about the current 2-wire mode, since that's what you're going to run into more of out in the field. Since the sensors we are testing are passively powered, we're going to need an external power supply to simulate the signal. So notice while we're in current source mode, our black terminal is the common and the red terminal is our PLC input. Now we're going to go back and go into current 2-wire mode. Now the black terminal is going to say EXPS plus, which means external power supply plus. The red post is always going to be your PLC input. So the black post's functionality will change depending on which mode you're in. So looking back at our 4-wire circuit, we took the plus of the SIM-ALP2 or the red terminal and connected it to the PLC input. And we took the common of the PLC input and took it to the black post, completing our circuit. In the case of the current 2-wire device, we need this external power supply. So we're going to connect a wire from the plus 24 volt of our power supply to the black post of the SIM-ALP2. Then we're going to take a wire from the red post of the SIM-ALP2 and we're going to go to our PLC input. And finally, the common of our PLC input is going to go back to the minus of our power supply. So I've connected a wire to the plus 24 volt of our DC power supply, and I'm going to put that to the black terminal of the SIM-ALP2. Then we'll take the same wire that we had going to our PLC input previously on current source mode, and it's still going to go to the red post. But the final connection, and honestly the most overlooked one, is we still need a connection from the common of our PLC back to the minus of our power supply. Now let's talk about a great feature of the SIM-ALP2, which is its open wire detection. We're showing 20 milliamp on the SIM-ALP2, and our PLC is showing 20 milliamp. Now let's take the wire off of our red post. Now we're still showing 20 milliamp on the SIM-ALP2, but we're not showing 20 milliamp on our PLC. And now we have this open wire banner here. And what that means, there's not a continuous path from the external power supply through the SIM-ALP2 and the rest of the circuit back to the external power supply is common, or mainly current cannot flow through the circuit. We touch it back, the banner goes away, and we're showing 20 milliamp. We remove it, the open wire banner comes back. The final mode is voltage source. If we go back out and we go into voltage source, then our terminal assignments are going to be common goes to the black, and our PLC input goes to the red. VI0 is going to be our voltage input, and we're going to use that same common wire that we were using in current source and current 2 wire. Now we run the voltage source up, and we see the signal going up on the touch screen. Now let's go into the settings screen and see how we can customize the SIM-ALP2 to suit your needs. First, we have ranges, and under ranges we have current range, voltage range, and resolution. And if we go into current range, our default range is going to be 0 to 22 milliamps, which is going to be the full scale that the SIM-ALP2 can output. But a more common signal would be either 0 to 20 milliamps or 4 to 20 milliamps. Now here's the big difference with this is if we press OK to 4 to 20 milliamps and we go back and we go to current source, instead of starting at 0 milliamp, now it's going to start at 4 milliamp. Also, if we press the down arrow and try to go below it, we're going to get this range limit. And if we go up to 20, then we're going to get that same range limit. So this is a way you can limit the range of the SIM-ALP2 for your particular application. If we go back to settings and back into ranges and voltage range, then we can actually simulate a -10 to +10 volt signal, and that is the default range. Or we can go 0 to 10 volt or 0 to 5 volt. So in the range we're at, if we go back to voltage source, then if we hit the down arrow, it will actually go past 0 volt and go on into the negative, which is really useful if you're simulating, say, a servo speed command or something that uses a -10 to +10 volt signal. Let's say we didn't want it to go into negative, then we can simply go to settings, ranges, voltage range, and set it to 0 to 10 volt. And now, when we go to voltage source, we're not going to be able to drive a signal down into the negative range. Back at ranges, the other thing was the resolution. And we have 2 resolutions. We have 1/10 of a unit increments, and then we have whole unit increments. But it also changes another feature when you select these. So if we're on 0.1, we have the option of doing our step cycle, sweep cycle, and custom profile. If we go to 1.0 increments, then we go into calibration mode. So if I select it, then when I press the OK button, it's no longer going to bring the sweep, step, and custom profile cycle menu up. We're going to get to calibration mode. And what this is for is, let's say in your particular application, the SIM-ALP2 is showing 10 volt and our PLC was not showing 10 volt. In fact, let me throw that value off for us. I've thrown off the scaling in the PLC, so it is displaying 10.5 volt, even though the SIM-ALP2 is outputting 10 volt. Now let's say for your particular application, you're sure that you want this to show 10 volt right now. While we're in 1.0 resolution, we can press the OK button to go into calibration mode. And now I can use the down arrow to lower the output value at 10 volt. Press OK, and now we're calibrated so that this shows 10 volt DC. Also, each point can be individually calibrated. So if I go down to 9 volt now, You see it shows 9.4. So we can adjust each point as we go. And current and voltage are individually calibrated. So let me change my setup for current source. Now if we go into current source, I'm outputting 20 milliamps here. I'm also outputting 20 milliamps here. So it didn't throw the scaling off. But let me throw the scaling off in the PLC for milliamps so we can go through calibrating it as well. Okay, now we're outputting 20 milliamps, but we're displaying 21. And again, we probably should fix the problem, but let's say that we're sure that whatever we're outputting here, we want to show 20 milliamps. We press the OK button. We can bring that signal down. Then press the OK button. And now 20 milliamps on our ALP2 is 20 milliamps on our PLC. One other thing to note, let's say we get into that calibration mode and we accidentally run this up and we didn't mean to. So now let's say in 20 milliamps, 20.6. If I hit the cancel button, it'll go back to the setting it was at. Now the only thing to remember is if you're in the whole numbers, then you can't use the sweep, step, and custom profile cycles. So if you're just going in there to adjust a number, don't forget to go back to settings, ranges, resolution, and change that back to 0.1. Also, another advantage of the whole number increments is obviously you can run through the scale 10 times faster than you can with the 0.1 increment scale. Also, while in one of the simulation modes, in the top left, you can see your range. So right now we're in a 4 to 20 milliamp range, and we're at 0.1 resolution. If we just go back to settings and ranges, and first we're going to change our current range back to 22 milliamp, and we're going to change our resolution back to 1. Now when we go into a simulation mode, in the top left it's going to say 0 to 22 milliamp and 1 unit increments. Now let's go to the EU scaling, or engineering unit scaling. And this is very useful when you're trying to work out in your mind exactly what milliamps is what value. Let's say we had an actuated ball valve and 4 milliamps represents 0 degrees or the valve being closed, and 20 milliamps represents 90 degrees or the valve being open. Then we can go to our current engineering units high, and our 20 milliamp value we would want to be 90 degrees. And our engineering unit low for current, we would want to be 0 degrees. Now if we go back to current source, we're showing 20 milliamp as our output, but right below it is our scaled value, and it is at 90, and that represents 90 degrees. And then say we want it 45 degrees, we can now look at our scaled value and we can bring it down to 45 degrees, and it's 12 milliamps. So that's a really useful feature. Next we have options. And under options, first we have a sleep timer, and that can help save the battery life of the SIM-ALP2. And its default is going to be on 5 minutes, and you can adjust this, or if you bring it all the way down, you can disable it. And the same with the LCD timer. We can bring it up, and in this case, after 5 minutes, it would dim the LCD to help save battery life, or we can bring it all the way down and it'll be disabled. And we have an LCD brightness that we can also adjust. Next, we have diagnostics. And this is mainly for our use. If you're having trouble, we may ask you about something on this screen. But if we short the two terminals together, then we should get all OKs over here, and this open wire banner here should disappear. And as long as you have all OKs, then don't worry about what these numbers are. That means that the SIM-ALP2 is functioning properly. Next we have factory reset, and that will take it back to exactly as it was when we shipped it to you. We've already been over the quick start guide. That'll just bring up those basic instructions of how to get you started simulating. And finally, we have the About section. It's going to give you the part number, the series, the revision, and the serial number. And if you press OK, it's going to give you a link to the manual. And if we take any QR scanning app and we scan it, then it's going to give us a link to get directly to the manual. And here we can find details of all of the latest features of the SIM-ALP2. I'll put a link in the description to the PLC Tools SIM-ALP2 where you can find more information about it, and you can also find numerous application examples of it being used with different manufacturers' devices. Till next time.